for our students to use. So essentially, I'm just kind of guidelining him through. He missed the meeting. I believe you sent him a version of Demetra for Lisa, and he's been beta testing that, but he was not able to attend this meeting. So I'm just kind of here for his purpose.
Okay. But you will be using the eShel or the ligne?
Demetra, we would like to use Demetra. We'd like to use something that's essentially very easy interface for our students for our laboratory course.
Okay, but for which instrument you plan to use Demetra?
It's for Lisa.
For the Lisa, okay.
Okay.
Yes.
And not for eShel? You have an eShel in Cal Poly?
Yes.
And,
so Jonathan Hood was the person that you were working with, the student.
Okay, perfect.
Okay, Matt?
Sorry, trying to find the unmute button. Yeah, Matt Nelson, University of Virginia. We picked up eShel about, I can't remember, 6-7 years ago, something like that. And the original intent was to use it in our undergraduate and graduate lab classes. We more or less shelved the unit because of the difficulties of getting it to work with Autola. We recently have been pursuing a bunch of follow-up targets from both our SDSS survey project as well as tests. And so we've put the eShel on our 0.8 meter here in Virginia, and it's been fairly successful. And frankly, the Demetra betas came out at just the time we were doing this, which was very, very happy for us. Being able to move away from the old software into this new software has really helped us keep the programs rolling along.
Good.
Thank you. Howard?
Yeah, hi, my name is Howard Tracci. I'm a professor of physics at a university in suburban Vancouver called Simon Fraser University, although I just took early retirement. I submitted the grades for my last course just a few weeks ago, and hitting return was like the last thing that I did. And so I just want to mention, first of all, both the eShel and the Lisa. We've had both of them at my university, the eShel for about 5 years and the Lisa for about 3. I'm not a professional astronomer, although I'm a serious amateur, and I've taught astronomy for many, many years. I've always wanted to do astronomical spectroscopy my entire adult life, but never had an instrument to do that. And when the eShel arrived, it was like a bomb blew up in my office. I went completely crazy over using it. And then we got the Lisa to have something complementary to the eShel, high resolution on the one hand and then higher sensitivity on the other. And so I spent a lot of time digging into both Autola and especially ISIS, which both have been mentioned. So ISIS in particular, very, very powerful software for all kinds of analysis, but with an extraordinarily steep learning curve. And so I spent months and months learning enough about ISIS to be able to do enough analysis. And then Autola is not bad for data acquisition for the eShel, but not as good for the Lisa. And so having Demetra, which does both acquisition and analysis in the same package and doesn't require months to learn how to use it, is like almost out of the box. It's a huge step forward. And I have colleagues that I know who are frustrated by using both ISIS and Autola. And so this really makes things much, much simpler. My university, we've already used particularly the eShel with students, and we designed student projects, and I wrote a whole manual on how to use ISIS for data analysis because I knew the students would not be able to cope without it. And so that I throw that out now. We have Demetra to take care of both of those. And I think for Shellyak, this must be a huge advance because many of your customers will maybe find ISIS and Autola an impediment to using it. And so it's a huge progress. I'm a big fan. I also acquired. I have a new telescope, incidentally, coming to me personally, and I was able to afford a Lisa for myself, and so that just took delivery, and then the next week or two, installation and testing. So I'm very, very excited. A Lisa for me personally will be something that I plan to continue using.
And it would be a remote instrument, right?
It's a remote instrument in the Sierra Nevada observatories outside Fresno, California, which I visited last fall. And so very, very exciting times for me personally. And the Lisa and Demetra will be a big part of that.
Eric?
I'm Eric Jensen. I'm at Swarthmore College, just outside Philadelphia. We've had an eShel for quite some time, but I have never really found the time to, get a good workflow working for acquisition and guiding. And we have a 0.6 meter telescope, and we have f7.8, and we have pretty poor seeing. And so we're not really well matched to the spectrograph itself, but I haven't really dug into working with, getting a focal reducer on there and figuring out a good guiding workflow for that. And so I'm just finishing up the semester, and I have a sabbatical this coming year. So I'm hoping to finally find some time to be able to take this instrument that we've had, basically, as a few other people have mentioned, just sitting on the shelf for a long time, and be able to really make use of it and learn myself enough how to use it well to then be able to use it for some projects and to use it with students. And so this workshop and this new software coming out was mostly just an opportunity for me to motivate myself to start to get back into it a bit, and and hopefully finally figure out what we can do with it. So I'm looking forward to it.
Okay. Okay.
Jason?
Yes, great to be with you. This is Jason. I'm a professor at Embry-Riddle Aeronautical University in Daytona Beach, Florida. We've had an eShel probably for 5 years now, and we really have learned to use the Adela software pretty well. It's when we got the new collimator that extended the wavelength coverage down into the blue that we got excited about calcium H and K work, because we have a 1 meter telescope, and even though not a lot of a quantum efficiency down there for bright stars, we can go all the way down there. And it was a little bit tricky to get Adela to extract those lowest orders. And I was hoping Demetra might be able to help us with that.
Okay.
So I had a student do a master's thesis and was able to reproduce some spectroscopic binary orbits with the eShel. And I independently reduced the data with IRAF and got about the same answer. So we were pretty confident on the wavelength calibration and everything else. So we've been very happy with the instrument. And I too am going on sabbatical this year. And although getting that whole thing working is not my primary focus, I would like to get the new software working so our students can take advantage of it next spring when we have our big observational astronomy class. So I'm excited to learn about the new software.
Thank you. James? James?
Hi, I'm James Clem. I work at Grove City College, professor at Grove City College, Western Pennsylvania. We have a 1/2 meter telescope. It's an F10. We've had an eShel for about 2 years. It took me about 6 months to get it installed and set up. But this past fall semester, I've had some observational astronomy students do a semester project using the eShel, trying to get spectroscopic binary orbits. They were successful in getting a radial velocity for Vega using ISIS. But they had some difficulty differentiating the lines of the two components in the binary. But one of the biggest difficulties, and I'm grateful for an introduction to this software, because ISIS is rather complicated in some ways in order to train a student how to use. And so I'm hoping to have the ability to use it a little bit more efficiently and train students a little bit better with it.
Thank you. On Cheliac side, so Olivier, please. Olivier?
Yes, so my name is Olivier Garde. I work for Cheliac Instrument since 3 years now, for communication, and I am work also on some technical parts in spectroscopy. I have my own observatory in the southeast of France, with all the spectroscope cell by Cheliac. So I have an LP600, I have LISA, I have an eShel spectrograph, I have the great Whoop shell spectrograph about resolution about 30,000, and so I do many spectra with this different setup. So I try to help Cheliac to develop new spectrograph and do communication for amateur astronomer.
Nicolas?
Hello, I'm Nicolas Durand. I am the software developer of Demetra. I'm here since the beginning with François. We started to develop it 8 years ago. And I'm not speaking English very well, so I will keep short.
Okay, François?
Okay, well, hello to everybody. I'm François Cochard. I'm the co-founder and the general manager of Cheliac Instrument. And well, also my English is not that good, but I do my best. And of course, you tell me if what I'm saying is not easy to understand.
Okay.
So Alain, we start or?
Yeah, just to begin, Howard, you have already give your feedback, but do you have a few words to say about Demetra, the advantage of this software on the precedent one?
For sure. So I've mostly used it with the LISA and a little bit of analysis of some eShel data that we took before. And so because I was going to get the LISA for myself, I actually took the LISA we have at my university home to play with. And so I did data acquisition and analysis, like solar spectrum, just opening it up in my living room. And so it really was extremely quick. The acquisition is painless. And then I fed the data that I just took right there, right into the analysis side, and had the graphs plotted in minutes, which is a huge step forward compared to Au-delà and LISA. I used to use Au-delà in the beginning for analysis as well. When I finally got a handle on ISIS, I used that. And it has a lot of very powerful features, many of which are not documented, but and so I still use it occasionally for some analysis after I feed the data through Demetra. But it's just having it all in one package, both the analysis and the acquisition, the ability to analyze your data in that program right after you've acquired it. I think for our students in particular, for me, this is very exciting, but for our students to be able to do that right there without having to import it into another program, convert the file names and all that, it's just, there's that, which is you do, but there was that sort of overhead, never mind learning how to use ISIS itself to do the analysis. The idea that it's all self-contained is very, very good. So I'll be using Demetra for my own personal LISA routinely going forward. I also experimented with MIDAS, the European analog of IRF, to analyze some LISA data and got the same results, and that was very encouraging. But again, it's just the convenience. The GUI interface is straightforward. You know where to put all the files. You know which buttons to press, and so that simplifies things enormously. I had a colleague from another university in Canada that came to visit us at SFU last year because he had the eShel and he was very frustrated because he could not get a handle of ISIS. And so he came to visit and we spent several days going over how to use ISIS to analyze his data. So I know from my own experience and his that can be a real impediment, and it's understandable. The documentation for ISIS is in French, and I speak French, and so that helped me to sort of translate. But it was bits and pieces everywhere, and so you have the manual for ALPI version of Demetra, and I imagine you're going to update that for both LISA and eShel, which will be great. I mean, analyzing eShel data is far more complicated than doing LISA, and I'm astonished that your eShel program, Nicolas, can just do that by pressing a button. That's I think really quite extraordinary. But documentation will be helpful because there are many more parameters to look at in that case.
Thank you, Howard, and thank you to Matt also because you both were part of beta test team, and you brought a lot of remark and valuable feedback for Nicolas and François. François, you present the software.
Yep. Well, as an introduction, well, I will share my screen. Can you see my screen?
Yes, I can see it.
Yeah. Okay.
Yes.
Okay. Perfect.
Yes.
So you just you all talked about ISIS and Au-delà. Just a quick reminder. ISIS software, for I guess that not everybody know it. ISIS software is a software written by Christian Bruil. Christian Bruil is a French amateur astronomer, but he's also an aerospace engineer. He works at CNES, so the National Center for Space and I don't know what's in French. So it's an important science research center. And he's an optician, and then he did create most of he did design most of the optics of our instruments. And in fact, if Christian would not exist, Shelia could not exist for sure. Okay, and he did also this software ISIS to process the data he got from the different instruments we had. And so ISIS is a very, very powerful software, as you said, Howard. The problem is this is the software that Christian made for himself. And Christian has a special way of thinking, like everybody. And in fact, we are very lucky because he shares this software. But really, this is his software first, and it's not really easy to enter in, even if all the functions have really the capability of the software is incredible. So,
sorry to interrupt you, François. I just wanted to say that I'm a huge admirer of Christian's work. His website is an amazing resource, and I've looked at it again and again for ideas for projects to work on. So if anybody doesn't know his website, I highly recommend looking at it.
Yeah, and for sure. Well, this guy is incredible, and the ISIS software is also incredible. But this is not easy to understand. And really, this is a software for which you can use any spectroscope you want. And the problem is that they have many features. The problem is that if you have a specific spectroscope, it's not easy to understand how you have to process. And well, this is the way. And then we did. When we designed the eShel spectroscope, so it was some time ago, I think it is more than 10 years ago, we did create a dedicated software module within the Au-delà software. And Au-delà is an open source software made by a team, a whole team in France, mainly in France, but in other countries also. And this was a very, very clever software, I think. The problem, the big problem of Au-delà is that it never had the success it should. And today, when we looked at with some distance, we see that in fact, when we did start with the Au-delà, we made the choice, or the guys who did that made the choice of the TK language, and he hesitated with Python, and it was really at the beginning of the Python. And the problem, well, if it were in Python today, I'm sure it would be the most common, most used software in astronomy, because it is very, very clever. But because of this, it is still and it has still a very little audience. And in fact, we did a great, I think, a great software module for the eShel data reduction in Au-delà, but the problem is that this software now is very difficult to update and to maintain, and continuing to work with this is would be really I think it would be a mistake from our standpoint. Then we decided a few years ago to create a new software with the new languages and modern tools, and we use the C# and this is Demetra. And the idea really for me is very very simple when we do that. So the idea is that we want to have a software that helps us to do spectroscopy, because, well, usually speaking, you know that part of our users are half professional and half amateurs, and really I know that for a lot of people taking spectra is the fun part, but processing the data is complex, and we had to use some of the existing software, and really we thought that we could do much better. So the idea of Demetra is really to help us to take and process spectroscopic data and in a very easy and quick way. What is important also is, so we start from the acquisition and we go up to the data reduction. And the idea also is really to have something, the idea, it must be so easy that we finish the observing night with the data already processed. Okay, so we don't have to wait for the next day to process the data, because it is so easy. And so this is really the idea of this Demetra software. It must help the user to do spectroscopy, to do observations, and well, I forgot what I wanted to say. That's not a problem. Now, so this is, I hope that you can see my screen. When you launch Demetra, you have mainly two buttons. So you have the name of the instrument, and when you switch from one instrument to the other, you can use it for the LP or for the ELISA. So this is the same software, but you have different packages attached with the different demonstration image, demo images. But in this configuration, I am in the eShel configuration. I have two buttons, one to manage the observation. This is the one I will go to. And the other one is to take spectra. When it is connected to the camera of your eShel. Okay, so I will at the moment I don't have any spectra connected to my computer, so I go directly to the management of the observation, and I work with the demo images to help you also. You can do the same when you download the software package. You can do the same at home. Something important, we have released Demetra for the LP today, and the version for the ELISA and for the eShel are still in beta version, and we are, thanks to some of you guys, we are doing a lot of progress on this eShel version, and I hope that in few weeks, months, perhaps at latest, we will release the official version of the eShel Demetra. Okay, this is a demo image. So here is how where we organize the observation. So I have here an observation of the sun. Okay, and in Demetra, an observation, this is important. This is a set of images, a consistent set of images. And for this observation, I've defined the name. Well, in this case, it was just the sun, an easy one to do. I have some information regarding the context, so I can give the name of the observer, the observing site, the hardware device we used, and so on. And we also have for this observation the list of the images that are linked to this image, this observation. Okay, so you don't have anymore to take images and remember in a few months from now which dark images I took for this observation and which calibration image I took and so on. All is collecting in a single observation set. Okay, and when I click on this object, for instance, I can double click on the image and I see the image in the bottom part of my screen. Okay, so I hope that it is fast enough. You can see the screen moving. Yeah. Okay. Fine.
Yes.
Thank you. You can see, for instance, here you have the blue area in which we calculate the profile in this blue area, which is one of the order, which is the order 40. Here I can read it here, and I can display in real time. Even during the acquisition, this is important, even during the acquisition, I can see a quick view of the data. It is not totally processed. This is really a raw image, but it gives you a great idea of what is in your spectrum. Okay, and I can move from one order to the other, and then I will see all the different orders in my image. Okay. And I can double click on any image here and see the difference in the profile. I can look at my bias images. I have a lot of things here to tune the image. I can zoom in it. I can move it. I can do what I want to manage to display the image. I can extend it horizontally, which is very useful in spectroscopy. And well, that's it. And I also have so I have the bias image, the dark image, flat image. So this is a flat, and again I can extend it like that and that. And I have also my calibration images. Okay, and so you may be familiar with that because we have all seen eShel spectra. By the way, I think this is Steve who is who will work only with the LISA, if I'm right. And in this case,
yes.
okay, thank you. The image is much less simple, but much simpler. Sorry, but the idea is really the same. We have also the kind of observations. We see the images and so on, and after that we have the data reduction tab, and the data reduction will be different for the LISA or for the LP. Okay, and for the from the eShel. Okay, so when I've collected,
François, I'm sorry to interrupt. Could I ask a question about the calibration? Since I haven't been able to use Demetra to take data with the eShel. So the flats, will it turn on both the LED and tungsten lamps in the acquisition phase, or how does it handle that now?
Well, this is I think a little bit technical questions, but I know that well, I hope. Well, today we don't use anymore the LED, the blue LEDs. Okay. I think that what you are saying, what you are talking about is the fact that in Odela, you have to finally tune the parameters to be sure to catch all the orders, as many orders as possible. In Demetra, and this was very, very dependent on the thresholds you get for these parameters to detect the orders. In Demetra, we have a totally different way to detect the orders, and in fact, I can give you in few seconds, but I don't want to spend too much time because Alain will stop me.
You can tell me about that later. You can tell me about it later.
Yeah. But just in fact, we do a cut of this image and we consider as if it were a spectrum. So, and then we detect all the lines in this spectrum. So we don't have anymore these parameters that have to be tuned to detect all the orders. So we are much more sensitive than before. Okay. And then, well, very, very quickly, the idea is that we collect all the images for a given observation. And after that, we just go to the data reduction tab and we just have to run. So we have the different steps for the data reduction. I just have to click on the button here and all the steps will go through quite quickly. In this case, it's a little bit slower on my computer because of the Zoom communication. But anyway, in few seconds, it will be done. You see all what Demetra is doing with the images, all the process is doing. We keep, of course, the log file for this observation. And then in few seconds, you have the result. Well, it's working on the extraction. It will be done in still a few seconds. Well, it is slower than usually. Anyway, it's really a few seconds. And then at the end, you just have the fully processed data. Okay, stacking, the blaze correction. And something very important, I'm saying that doing when it is still working, I can always double click on an image before for each step. For instance, I've been to the master image. I can double click on my image here and see exactly what image it is. Okay, and I can also double click on the after image. Well, okay, so it is finished. So now it displayed the result of the image, and I can see all the different orders. I can see, for instance, the order 34 in which we have H alpha in the sun spectrum. Okay, so this is the result. We immediately have the result, and I can fit my image again. And well, in this part, what is very important, we have split the process in very clear steps. Okay, and for each step you can run it manually and see what are the images before and what are the results after this step. Okay, so for educational purpose this is very important. A lot of you are working with students, and really you can do, and I really recommend to do the first processing step by step to understand what you are doing with your images. Okay, so this is the idea. It's something very embedded, very automatic, and this is important. We want to have something easy to use, but we want to keep the control. So I don't want to have a black box on which I just click on run and I don't know what happens to my data. So you are responsible for your data and for your results, and then you must be able to see what happens to your data and if anything went wrong. Okay, and the last tab at the end is just to show the results, and you have all the different orders with the small color band that matches to the real color of the spectrum. Okay, so we don't have the order number. We will add very soon the order number to this part, of course. Okay, so this is really the idea.
I had a quick question, if you don't mind.
Sure.
Is that continuum subtracted, or is that just not response corrected?
No, it is not response corrected.
But is it continuum subtracted?
You can use a response curve, but in this case, you have a response curve correction included in the process. Okay. In this case, in this particular case, I didn't select it, so it means that it is not response corrected. Okay, but the ability is there, and this is a quite complex question because we have a tool here to build the response curve. Okay, so this is something that we're still working on to improve it and to make it easier to use. But really, the idea is that you can take a reference star spectrum, use a spectrum reference library from the library, and then build your own response curve. Okay, and then you can apply it to your own observation.
Okay.
Okay.
If I could just jump in on that question that was asked about a background subtraction. So I've been a little bit lazy in using the eShel and not, going off target and taking a background sky, because I've usually relied on done relatively bright stars where I hope the background wouldn't be necessary. But that's a very good question. What if you did want to subtract the background? Would you be able to build in a feature for doing that? Say if you went off target and collected background data.
And the problem is with the eShel is that this is a fiber-fed spectroscope, and then you cannot get the sky background at the same time as the star itself. So you can do it with an LP, you can do it with the LISA, and with the LP or the LISA, we subtract the sky background because we have it, but in the eShel we don't have it. So if you want to correct it, you just have to do another spectrum, another observation on the sky background beside your observation, and then you have to manually do the subtraction.
Okay. Just 2 words to say, we have a call en route coming from Concordia in California with us.
Good.
Another question?
Well, I think yes, I can stop here for the general presentation. Well, something that I didn't show you here is if I go, all the colors here are green, but if I see, for instance, that I remove all the images, can I do it? Yeah. Hop, if I remove the calibration images from the observation, the calibration basket becomes red, and and all the observation becomes red. Okay, so this is something important. In this case, the observation is already fulfilled, so it's easy. But when we start a new observation, you can really do you can use this color coding to help you. Can I paste? The system is not responding anymore. Okay. So sorry, are you still here? Yeah. Can you hear me?
Oh yes, yeah.
Okay. Okay, so I've been, well, I don't know what was wrong with my keyboard, but I did did it again. And something important is when you have finished your first observation, you can create a new one. And then if you create a new observation, then it will be all red, of course, because all the baskets are empty. Okay, you have to go to the definition and so on. But there is another way which is much simpler, I think, is to copy your observation. So you can either do it using the copy button or use the copy button in the button and say I have a new obs2. Sorry. Hey. Interesting. I'm in the British keyboard and maybe this was the problem. Okay. Sorry, here am I. And here, when I copy the observation, I can select what are the baskets that I will reuse. Okay, so when I do that, of course, for the bias image, for the flat image, and so on, you will not redo the image for each observation. And then you just have, when you create this new observation and you go to the image, you can see that we have reused all the flat fields and so on from the previous observation, and you just have to take your target spectra to fulfill the observation. Okay, and of course, also something technically important. All the data for a given observation session, and observing session means one observing night usually. All these data are collected in a single folder, so it's very easy to archive the data. They are all in, and if you collect data from another folder on your hard drive, then it will be copied to this session folder. Okay, and of course, if you are reusing the darks are not copied several times. This is just the link to the dark that is copied in many observations. Okay. So I think I stop here, and just know if you have questions, we can discuss, and we can, of course, I can go back to details.
Yeah, I've got a question. I've been pushing our eShel to fairly faint magnitudes, and so one of the things I've been doing is taking very extensive bias darks and flats that involve an awful lot of files. Do you have a mechanism for copying the reduced masters into an observation? All I've been doing is just adding it, for the bias, for instance, I'll just add the master alone by itself.
Okay, well.
It's a little bit cumbersome, and the reason I'm doing this is I don't want to do that reduction, because often I'm having to loop through the full reduction to get everything finished up, and the processing time is significant when I've got 100, 200 files.
Okay, this is very interesting. We at the beginning we say that well, we could do something clever to check if the master calculation have been already done, and to avoid losing time to do it and so on. But we didn't do it, in fact, because usually we have only few images. I mean, well, not hundreds, and maybe we can add something to make this in a better way. But for the short time, I think that there is a very simple solution, which is in your new observation, when you are talking about the bias, you just put the master image from your previous observation. And
yeah,
then
that's what I've been doing.
Yeah. Okay. And then it will just take one image, and it will do the master of one image, which is the same image, and that's it.
Yeah, as long as that's okay, because what's going on in the pre-processing is something of a black box, and I wanted to make sure that nothing untoward was happening if I did that.
No. I've done the same with masters. Yeah, I've done the same thing with masters as well. Sometimes I don't take fresh darks from one night to the next. It doesn't have to always be updated. So I've been routinely doing that. Yeah.
Yeah, well, if you have dark and gas library, because you have already collected data at different temperatures, different exposure times, and so on, you can really have in any folder your library, and you just have to pick up the master in your library, and this master will be copied in your session observation.
Yeah.
Session folder. So.
It might be worthwhile to the users who haven't used the software a lot for you to discuss the importance of the various validate buttons in the software.
Sorry, I'm not sure to have understood.
Yeah, there's a couple spots where, for instance, doing in order detection when you're setting up the reference order, once you've identified it, there's a button called validate.
Okay.
And that's very important. If you don't press that button, the reduction will fail again. And it's the same thing when you're going through calibration, and one by one in the orders, you're tweaking up, you know, in the advanced page, you know, if you don't hit that validate button and you rerun the reduction, what you just did in terms of changing parameters does not get saved and redone. So making sure people understand how important those validate buttons are, I think is good to pass along.
Okay, so there are many things in what you are saying. One is, yes, I've been very fast. I just told you that you just have to click on run button and that works. In fact, it works because we have tuned a few parameters. And for instance, you are talking about the order detection step, for instance. We have a tool here to detect where it is. Okay, no, I have to run the process again, and if I go to the order detection here, I should be able to go to the results. Well, anyway, maybe I have to wait until the end of the process. I'm not sure.
You don't have to wait. It just takes a while to pop up.
Yeah. Okay, sorry. So here, for instance, you have this button, and this is a tool to help you selecting the reference order, which is usually the order 34 for the eShel, which is the H alpha order. And you are right that if I change something, I have to validate the system. And this is a permanent the question we have with Nicola. And the point is that if we do that automatically, because of the calculation behind, it is very slow. So we prefer to move it this way and to have this button validate in red. But for sure, we have the color coding in Demetra. When it is red, it means that you have to take care of this. Okay, and you have to be very so if there is some red color somewhere, it means that there is a problem. And in this case, I think even if we have we have forgotten some, but normally each time that you have to click on a validate button, it becomes red. Are you okay with that, Matt?
Yeah, I'm familiar with it. I just wanted to make sure that this was obvious to everybody that this is important to do, because when you first use the program, it has no idea. At least for me, it was, you know, the reference order was showing up down around 45, and so the whole process would fail. And the first thing it would do is say no reference order selected. You have to go back and redo it, and then come down, and then finally you've got something up on the screen that you can do the selection on. Understanding that there are these steps where you're setting things for the software that are very important to make sure the reduction runs from end to end properly is all I was getting at.
I fully agree. I fully agree. Yes, you're right. When we do, for instance, the separation of the orders, here, this is my general image, the image before the separation for the order 34, for instance. And when I double click on it here, I have the result of the separation. So we just extracted the order number 34 here. And yes, you are right. When you can run the image one by one. Here, for instance, I can rerun just this image, or I can run the whole series of the image. And this is for one order. And if I want to select and to do the same for all the order, I have to tick the run order button here to make this. And in this case, I will do the calculation for all the orders and all the images of the series. So I know that sometimes it's quite complex to say, hey, why there are so many buttons? But in fact, the idea was really that we want to have the control of any single operation. And well, this is the best we have found so far for the ergonomy of the system. And I don't know why it is blocked at the separation order. Anyway, this is, I can rerun again, but I think this is detailed. I don't know what I did. Any other questions or remark?
This is Jason. I have a question. For the Alpi version, do you have a choice of calibration lamps? For example, we feed our thorium argon lamp into our Alpi when it's connected to one telescope, but we have Alpis on smaller telescopes that have your helium neon or the neon lamp. I don't remember which it is.
Okay, so well, I consider this is a general question. Oh yes, I have the problem here because of course I've understood. Sorry, I just correct the point. What the mistake was that I moved the reference order, so behind that the calibration failed. Sorry, I come back to your question, Jason. Regarding the calibration, we have. I will start it again. We have a very rich tool. So the basic tool is the same for the Alpi, the LISA, and the eShel. But the difference for the eShel is that we used it many times. We use it for each order to do the calibration. But the idea is the same, and this is one of the algorithms in Demetra, which is very different from ISIS. You know, most of the algorithms we have in Demetra are the same as ISIS, because we worked with Christian, and Christian gave us his algorithms, thanks to him. And but for the calibration, we thought it was too complex. And in fact, the idea here is that we have two steps. First step is to automatically detect all the emission lines in your calibration lamp. And after that, the second step is to find the best match between these detected lines and the reference lines we have in the library. And what is important is that these reference lines in library can be edited, can be changed. So you can create your own reference line list, and then you can work with any kind of calibration lamp you want. The only thing is that if you change the lamp, you can do it, but you'll have to find all the reference lines in the spectrum to make sure to have the right detection. For instance, here I can open the tool for the calibration, and we have here we have the two steps. So this is the tool to help to do the automatic calibration. In normal conditions, the calibration is really totally automatic. So all the lines are detected automatically, and the identification to the reference list are automatic. If I look at the detection button here, you can see all the lines that have been detected by Demetra. Okay, so there are many lines, and you can even see look at some details here. For instance, we have blended lines here, which is properly detected. You have small lines here which are properly detected. Okay, so we detect all the lines in your calibration spectrum, and here in this bottom right column, you have all the reference lines for this order. Okay, so these are the theoretical lines, and then when I click on the identification, it finds the best match between the theoretical lines and the detected lines. And here is the result, and you can just have a look at what are the results, and you can see very quickly in this case that all the lines that have been identified are just high-level lines. So I'm sure that the calibration is perfect. And I can see also the result of the RMS, which is 0.008, which is very, very good, of course. Okay, but again, if you want to change, use another instrument, and you want to edit your reference line set, here it is. You can open it. So I just click on the reference line editor here, and you can edit the reference line here. You can save it under another name and so on. You can do many things. You can manipulate this reference line and adapt it to your own system. Okay. Do I answer your question, Jason?
Yeah, it was nice to see that interface.
Okay.
I just was wondering, for the Alpi version of this, it knows not only about thorium argon, but it has a built-in list for neon, for example.
Yes. And for the Alpi, the reference line set is the one for the argon neon, which is the embedded calibration lamp. And by the way, I don't know what well, I think we already did some tests of the thorium argon on the Alpi, but because of the low resolution, a lot of lines are bended. So
yeah,
I don't think
it's tricky.
useful, but it's a detail. Yeah, okay.
Yeah, if you could leave this page up for just a second. Oh, went away.
Oh, sorry. To go again.
Yeah, I wanted to ask about you know, the advanced page that you had. You know, there you go.
Sorry, this one?
Yeah, right here. This is
okay,
this is what I was struggling with yesterday. I had 2 orders that wouldn't solve properly, and I came in here and I was playing around with this, and I was finding for my data set numbers that were slightly better and were working better overall, but also were making the solution possible. And here's another spot where if you do a set and you get a good run, you have to hit validate in order to keep it for the full for the full reduction. But also, is there any way to change the defaults here? If I find numbers that work slightly better for my instrument and my setup, because right now it's just you get the defaults on all the orders, and you'd have to go and change them one by one.
In fact, this is well. So we are in a very technical part of the software. Huh? I hope that people looking at Demetra for the first time are not too afraid. And but this is an important part, of course. And really, you can. So this is something that you may have to adapt to your own setup for sure, depending on the focusing quality, your specific thorium argon lamp and things like that, and you may have to adapt this. If you have, you know that the calibration is made in 2 steps. We have a first step with the calibration detection, for which we detect the calibration for 2 given orders, one in the blue and one in the red part of the spectrum, and based on that we are able to extend the detection and the calibration to all the other orders. Okay, and so I don't know if this is the calibration detection that fails. You have to go to this tool and to understand exactly what are the lines that failed. And you have here the list. When I click on the detection, you have the list of the reference lines. And if I click on this button, the top right button, you have you can open a link to a reference spectrum, and then, so it's a little bit slow again, but it will open. And then here you have an example for each orders, for each order in the spectrum. It will arrive. Yes, here it is. And then it can be very helpful. And in fact, if really it fails on 1 or 2 orders, usually what we do is that we open this reference line and I switch to this line. I look at all these lines and I try to find all the lines that are detected and make sure that all these lines here are properly detected. And when the calibration fails, if it happens, it's really because one of the lines has not been detected. In fact, the algorithm is very robust, but there is one condition to make it work properly, which is that all the lines in the reference list here must be detected. this is not a problem if you have many more lines detected in the spectrum, but all these lines must be detected at least. You know?
Yeah, the specific problem I was having on order 37 was that with the default parameters, the minimum lambda was moved up well past pixel 100 or 150. And so there were lines to the left of that that were not being included. And it wasn't until I changed everything that, you know, it opened up and then the solution ran properly.
Okay. Well, you have the parameters here, which are the parameters for the line detections. And well, I will not go in details today because really we can spend time on that. But really now we have the tool, and if we have to spend time together to find exactly how it works, we'll do it. So I think for the moment, I think we are out of the subject. I think. But really, we have all the elements here to find what happened. And by the way, just a small addition to that. In fact, a few months ago, we did drastically improve the detection algorithm. And now we can really detect a lot of lines, much more than before. And we still have to update the reference line to make sure that it matches properly this algorithm. And this is probably where we have to do some improvements. You know, so it may happen that in your case you have to adapt this list to your own setup. But I'm sure that once we have done the time seriously for a given line set, then it will work for almost everybody.
I mean, just to follow up on that question, being able to, if you do decide to tune the parameters and you wanted to save them for quicker reuse or to apply from one order to other orders, that probably would be a complicated change to the software. But if one had that ability to retain changes that we want to make, that would be useful in some cases.
Well, okay, I know that we had the question to have a reset button because if you change all the values there, you say at the end, what was the origin values? And we probably had a reset button. But today, based on my experience, I'm quite sure that these parameters are quite general parameters that are fine, that work everywhere, every time.
Yeah,
but this is on the list here that we have to.
You wouldn't really need the reset button because you can only change the numbers for one order at a time. So you can always switch to another order, look at it, bring those numbers back in.
Yeah, all right. Yeah.
Sure.
Yes, but this is when you know where you can recover the figures. You can do it, of course. Yeah. But anyway, I think that we better have to work on the reference line list instead of the parameters. But well, this is a general statement. Maybe there are some cases where it's not true. But by the way, it can change also. These things can change if you don't have the same camera as the one we used to use for the eShel. So if you don't have the same pixel size and so on, maybe some of the lines can be detected or not, and this can change the reference line list.
Actually, I didn't mean to ask about that. Which camera did you use for this, and what bidding size did you use? Was it the Attic 460?
Yeah. In this case, the eShel I have at Sheliak is for the Attic 460EX, and the pixel size is 4.54 microns.
So I would often bin, if I remember correctly, for our measurements, given our plate scale. So so one thing that it looks like you got rid of those many parameters in ISIS where you would specify, the pixel coordinates of the left and right ends of the bands and so on. And you were saying if you were to use a different camera or if one were to bin differently, that could change. Is there some set of parameters that one would want to look at? Do you automatically find the ends?
In a perfect world, normally you don't have to change anything. Even if you change your camera, the algorithm doesn't require the pixel size, so it should work. But I know that in fact, we have some lines. Maybe I can show something here. Can I do it? Do I have some examples? No, I don't see. examples like that. But in some cases, you have, imagine that you have selected one of the, I'm zooming here. Imagine that you have selected this line as a reference line. You can do it because it is detected by the algorithm. Okay, if you look at it, it is detected. So I can use it as a reference line, but it's very dangerous. And maybe if you have another camera with different pixel size and different parameters, maybe this line can be not detected with another setup.
Right.
Okay, or imagine that if you have lost a little bit your focus, and then the lines are more extended, then it can go below the threshold and not be detected anymore. Okay, so it's really better. I'm sure that if you use large lines with something very the high lines like this, I'm sure that even if you are unfocused, you will see it. Okay.
And so the user doesn't have to specify, I mean, it sounds like your algorithm automatically finds each line and also the beginning and end of the line and so on. None of that's required to be specified by the user. Yeah.
No. This is totally automatic. This is really something. In fact, in the calibration, you know, it's always the same story. You have to select to have a list of matching pixel position and wavelengths, and based on this list, you fit a polynomial curve. Okay, so and this is always the same story. We all do, all the software do the same. But in Demetra, we have made a system in which the detection of the lines and the matching of the lines is automatic. Okay, in ISIS, you have to help the software to say, okay, this line is at this wavelength, this other line is at this other wavelength, the pixel size is blah 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 blah, and then ISIS has a process to detect step by step all the lines. But if one of the parameters is not good, then it will fail. In fact, you know, so in this case, we don't ask the user to tell me, well, this line at which wavelength it is. So it is totally transparent.
That's a very big help. What about like the orientation of the spots? Does your routine? I found it didn't really in ISIS. It wasn't so sensitive to specifying that angle. Is that something that you're just out of curiosity? Does your software
want me to answer that one for you, or
you seem to? Yeah, you seem to know.
It's when I was first switching over to Demetra, I had rotated the camera just to make the only a horizontal flip on getting the orientation right, and there was rotation, substantial rotation, maybe 20 degrees, and it worked, but it didn't work great. So, you know, if you get the rotation pretty close to what you'd expect to see from the reference documentation, that definitely helps.
Yeah, the overall
but
camera angle.
The algorithms are working just fine. And what the one thing you need to look for when you're doing the data reduction is look at the RMSs on the calibration. And if something's not around 0.01 or 0.02, you know you've got a problem. And then you can go in and look at them one by one. But for the most part, you know, everything will just pop out. It'll just run.
Yeah, and just to complete, this is perfect. By the way, I remember your image, Matt. It was very rotated. I confirm. But I don't. If the calibration failed, it was not because of the angle. It was because of the parameters and the detection parameters. I think, if I remember well. I think that the angle we don't care anymore about the angle. In ISIS, you have to really rotate the image very precisely to have it really horizontal because it is very sensitive. But in Demetra, in fact, this is why we have put this calibration detection image, the steps, in the data reduction process. The idea is that to take care about the rotation, in fact, we do the calibration in 2 different orders, and based on these 2 different orders, we can extend and we can extrapolate or interpolate and know where are the other orders. This is the way we found to prevent being sensitive to the image orientation.
If the image is mirrored, then things will fail. So you do have to make sure you've got the mirroring on the image correct.
Yes, that's right. Yes, that's what the algorithm looks for. The sure.
Could I ask a very basic question here?
Yeah, sure.
Yeah. So my very simple question is, will this run on Windows 7? We have a very old observatory computer that will need to be upgraded at some point. And the question is that point now or not?
No, it will work. It is compatible. Well, I'm not sure with the Windows XP, but for the Windows 7, it works.
Okay, thank you.
The main thing is you have sorry, François, 64.
Vas-y.
Comment on dit 64?
64.
64. You need
64
operating system.
Oh, does it? It has to be 64-bit.
Yeah.
Yes.
Okay, thanks.
It should work with Windows XP. I'm not sure because there is many years since I didn't check, so I'm not sure. But the important thing is you run it on a 64 operating system.
Okay, thanks.
So I confirm Demetra can't work with Windows XP. I try and it doesn't work because I have only 32 bytes, so it doesn't work with this OS.
Nicolas, we have to try on MS-DOS.
64-bit MS-DOS, if you can find it, maybe. Okay.
Can you get it to work on CPM?
Yes, we'll try.
Now, I have a question about these wavelength ranges on the calibrations. Are these hard-coded in because of the GRISM, or are these detected by the software?
Sorry, I didn't understand your point again.
All right, so right here on the screen, it says wavelength range, and you get like 4123 angstrom to 4236 angstrom. Are those ranges hard-coded in for each order, or are they detected by the software?
No, they are detected. They are detected.
Okay.
So if when you know that from one eShel to the other, depending on the grating angle, you can have a slightly different position of the lines and the position of the orders, and this is totally free. So even if you change the grating, it is totally free. It is detected. And again, this calibration is really detected for each order. We start detect for two given orders. In this case, the order 34 and the order 50. Okay, and based on that, we can extrapolate to all the other orders. So I can go there and see for each order what is the calibration result. Okay, so in this case, I have the image before, which is in pixels here, the scale. Okay, and when I click on after the calibration, I do have it in wavelengths. Okay, and it is calibrated and it is resampled to have a constant sampling for all the orders.
Or I know you already said this, but just to confirm, you did this calibration using thorium argon, yeah?
Yes, absolutely, yes.
Okay.
What is the units for RMS?
This is the wavelengths. This is the angstroms.
Angstroms, okay, thank you.
Good questions, yeah, okay. By the way, we have, where can I find the, c'est ça, c'est Nicolas, c'est report pour avoir l'image de. Ah, au secours, Nicolas. Comment je fais pour avoir l'image de calibration?
It's not a calibration detection step. It's calibration step.
It's in calibration step. Okay, show calibration. Sorry. Here it is. I was looking for this button here, and this is just to show the calibration results. So you have a summary of all the calibration for all the orders. Okay, and so I can extend my image, and I see that for each lines which is detected in the image, you have the wavelengths. Okay. And by the way, there are some small details. If I draw a rectangle, if I draw a rectangle here, and I can adapt the thresholds to this part of the spectrum. I try it again. Yes, to make appear all the lines. So this is the summary image in which you can see all the results for all the lines, and this image is very, you see immediately when the calibration is okay, because you see that all the lines that are surrounded are perfectly bright. So it's very useful just to double check that your calibration is okay. Okay. Any other question? Is there anybody there?
How will you announce future? How will you announce future releases to Demetra? Will it be just a general email announcement, or will you have a page, or will it have a built-in update feature?
Oh, this is a good point. First, we will most probably. I think that the best way for us to communicate is the Sheliak newsletter. So I invite you to register to this newsletter if it's not already the case. But also in your case, maybe most probably Alain will send you an email. When he has this kind of information, he will forward the information to you. And by the way, I can also look at the Sheliak website. And again, I will share my screen with the check. So can you see it? So this is the Sheliak instrument page, and here you have the official page for the Demetra, and we have prepared, we have made several tutorials. So for the moment, these tutorials are only dedicated to the LP, and we are still working on it. But really, I think we'll improve that, and we'll do the same for the eShel step by step. So you have a playlist in French and one in English, and then you can have a lot of tutorials. I think it can be useful for at least for the begin, the first tutorials. Oh, sorry, sheets. I didn't want to do that. For the tutorials, you can look at them for the first tutorials, because they talk about how to manipulate the image, what is an observation, and so on. So it can be useful because it is also valuable for the eShel. But we plan to do also tutorials like that for the eShel. Okay, then to have the latest news, go to the official Demetra webpage on the Sheliak website, and if you are not sure, you can always, of course, ask us if there is a new version. That's it.
This is Jason. I have one more quick question. We're trying to buy as many Alpies as my administration will let us, but in the meantime, in our introductory lab, we use the star analyzer, and I'm wondering if there's any plans to have some simple software my students can use to reduce data from star analyzer.
Well, for Demetra is not planned to be used with the star analyzer, and the star analyzer is in a slitless spectroscope, so it's very totally different. You cannot process the data the same way. We have no easy tool. I know that people are using either RSpec or maybe BAS software or things like that, but I think probably the most useful is the RSpec software from Tom Field, but this is so this is not a free software, and this is also it has a very good user interface as far as I know, but it is not made to really do very precise observations. This is something important in Demetra. We want absolutely to be as precise as possible in the results. So we really do something very serious, and we have a very well, not precise, but all the process steps that we have defined are made to get the best from your data. Okay, and this
That's
is
great. I'll check out RSpec. Thanks for reminding me about that.
Okay.
We've used RSpec with their video camera spectrum analyzer in class, and so that's it's useful, but you do have to pay for it.
So a quick question. You haven't talked at all about the acquisition side of things, and I know there's only time to do so much, but I was just curious, to what extent is it essential or just easier to do all the acquisition through Demetra as well as doing the processing there, or is it easy or hard to do? I don't have any other specific plan, but I'm just curious about sort of how tightly coupled they are and necessary to do it all the way through.
For me, there are some advantages to do both, so acquisition and data reduction in Demetra, because when you do that, well, the images are put directly in the right basket. And first, you also have some tools, some useful tools to check your data in real time. So you have some saturation detection. You can display in real time the profile of any order that you want. So this is something very useful. So you are acquiring spectroscopic data. So really, I think the idea is that if you do this both at the same time, then you just do quickly the acquisition, and all the data are properly put in the right place, and then you just have to click on the run button, and that's it. Okay. Now we have made. Sorry.
You skipped over in the main window setting up sequences. And I found that extremely useful for being able to work my way through a night of observations, is the sequences.
Okay, so this is a good point, and well, again, I will share my screen with the other. I go back to the ODLA, sorry, Demetra, and if I go to the text spectra here, yes, this is important. This is something I forgot to say. Well, I hope that you still have 3 or 4 hours in front of you, because we still have a lot of things to do. Well, I'm kidding. Here you can connect the camera, and we use only ASCOM driver cameras. So we have to use cameras with ASCOM driver. And if it is the case, we just connect it by this button. We can control the temperature and so on. And we can, of course, preview or record the images. And the idea here is that if I go to the for instance, if I go to my observation manager here, I have created my new observation. I have to collect my new target images. Okay, you remember? So I did create that. These baskets have been filled automatically. Now I have this one to collect. I can just go to acquire button, and then it switches to the acquisition button. I know here that I'm in the new observation, observation here, and I can just do a quick preview, for instance. Well, I have connected the ASCOM simulator here, so it's just not so this is an M42 image, so it's not very nice, and it doesn't have the right size and so on, but this is just to show you. And the idea here is that once I have found the right time, I can run my series of acquisition here, and then I click on start. Okay, and so I've asked for 3 images here of 1 second exposure. Okay, so when it is finished here, then I just have to click here, and I see that my 3 images arrived here. Okay, so it's really something very, very simple. Well, it's black because of course the size of the image is not the right one, so the order position is not at the right one. But this is well, just because I'm playing with the image like that. Okay. So you can switch very quickly from one to the other, and this is very easy. And there is something important here, is that you also have the connection to the calibration module of the eShel, and then you can control remotely, of course, the different buttons, and then you can switch from object to dark position, to flat position, to calibration position, and it will remotely control the calibration box. Okay, and on top of that, as you said, Matt, if I go back to to my observation, I have here an acquire sequence button. for which I can select an automatic acquisition sequence with different images. So I can, in one click here, just select, just do the acquisition of 20 darks and 10 flats and 3 calibration images and so on. And it will be done automatically. Okay.
Yeah, and there's a way of defining your own sequences as well in the main window, which is what I was getting to. That was very useful to me.
Okay, well, okay, and that's great because it's not very documented, but
I found it.
Yeah, perfect. That's good. It's here in the sequence. In the sequence, you can create a new sequence, and here you can give a name to your sequence and so on. And well, you have found it, and then you can edit it. And here you can add what kind of image you want, and do your own sequence of whatever you want. This is very important because the idea is that really 1 hour before the night, you just go to the observatory, you start your this reference sequence. It takes care of everything, and then when the night is there, you are ready to observe, and you just have to take the images from your observation, your target. And thank you for the reminder, Matt.
I've asked you about this before, Francois, by email. If you could put in a control of the LISA calibration lamps as part of the acquisition sequence, that would be very, very helpful. But I see that's built in for the eShel,
yeah.
which is great.
Well, it will be done very soon. In fact, we can remotely control the lamp for the LISA and for the LP and also for the LRS3 from the device that we call the SPOX. And we just have to add the SPOX device in Demetra. This is really the easy part. We'll do it for sure. We'll do it. It's not done it's not done yet. Sorry, but we'll do it.
That'd be very good. Thank you.
And for camera control, as long as there's an ASCOM driver for that camera, then should be able to use it.
Yep. Yeah. This is the condition. In fact, at the beginning, a few years ago, we wanted to be able to connect to any camera through their drivers, but it's so complex, so complicated to be up to date. Then we decided to stick to ASCOM, which is today really a very common platform.
This is Jason. Yeah, we have an old SBIG camera that won't work, but I'm glad to know you're using the ATIC 460 because we have a spare one of those we can put into service of our shell. So I'll let you know how that goes.
Good. Good. That's it?
Any other question?
No more questions, at least from me. I just wanted to say thank you very much for explaining all this, and I'm very excited to get to play around with the software.
Before to finish, maybe Francois, you can say some insight on the new version of Demetra.
Yes, very quickly. In fact, today, so we have currently a beta version. So it's not on the website yet. It's not public yet. But if you want to have it, of course you can. We are just finishing a new version which is more dedicated to the LP and LISA. And I hope that we'll be able to release the LISA version very soon. So we're just playing with some bugs at the moment. And our plan is that the next version, so the one that we call the 5.1.7, this one will be very dedicated to the eShel again. And I hope that it will be the release candidate for the eShel. And what will improve in this in this new version, this is the mainly around the how to display the image. We'll have to add a merge function to have a single spectrum merging all the orders. It doesn't exist yet today. And we also, well, I don't remember exactly, but we'll have to work on the last tab, the output tab, to have great results for the LISA and LP version. We can export all the results, all the images in a PNG, PDF formats, or some other formats, and this is not the case yet for the eShel, and we want to do it. In fact, we have to improve this output. And well, I don't remember, Nicola,
yes,
if
what
there...
come in my mind is instrumental response. Currently,
oh yes, of course.
it is a little. I don't know the
oh
English
yes,
word,
yes,
but
yeah.
it is long. It is long to set. It is very.
Yes, you are right. Today, yes,
set.
we quickly spoke about the calibration response curve. The response curve, sorry, not the calibration, the response curve. And today it is quite. We can do it in Demetra, but it is not that easy because you have to do that order by order, and it can be quite complex. And we will add some tools to have something simpler to manage. I don't have all the details yet, but we'll have something much more useful.
Are the response curves references you're working with canned at this point, or can you go and acquire your own response curves from known objects?
Oh, you can load your own response curve, no problem.
Oh, okay.
Of course, you can do your response curve with the tool you want and import it. When you select, when you activate the response curve, you can select your response file, which must be a fit profile. Is it okay?
I will start working with it and see if I can make sense of it. I may have questions to pass along.
Yeah, sure.
Okay. Yeah. Yes,
but anyway, Matt, we still have to finish our discussion. In fact, about the CMOS parameters, but we'll continue to discuss. Anyway.
Yeah, and I also have a bug report. I'll send it to you in an email.
Okay.
I got a quick question. Is there a manual available for Demetra, or is it kind of like try to figure it out by yourself?
Oh, it's much more fun to figure it out yourself than read a manual. Everybody knows that.
Thank you. No, anyway, we have a documentation. I'm sure it is not up to date anymore, but we can send you. We have a documentation to help you start with the eShel. But now, really, my feeling is that it's better to have short video tutorials. I don't know if you agree with that, but we make these tutorials very short. It's no more than 7 or 8 minutes, and for each step, and really we try to be focused on each part. And I think my feeling is it's better than writing documentation. But anyway, we have a documentation, written documentation. We can send it to you, of course.
I'll just add a comment. I'll just add a comment that I found the software to be well written enough that it's so intuitive that if you know what you're after, you can usually figure out how to do it in the software. So although there are some aspects of it that I would like to see some documentation on, in a matter of a few nights, I came up to speed pretty quickly on everything I needed to know to get results out of the software. So it's extremely well written software. My congratulations to you for doing this, and my thanks to you as well. I was not looking forward to running my projects with the old Autoless software.
Good, thank you.
Thank you. Thank you for all of us. So our ambition is to make a new meeting like that. Of course, we'll try to promote new things in Sheliak, but if you have some topics in mind, please send me an email and we'll organize maybe another workshop on your topic. So thanks